Welcome to Feynman's 10x. Today we are going to do an extremely hard integral question. And this integral is the integral from 0 to infinity x squared times x minus 1 over parentheses x squared plus 1 power of 3 lnx. And this integral is gonna be long, so I'm not going to talk too much in this integral. So I'm going to use the Feynman's 10x since you see the lnx is in the denominator. We're going to let r of a is equal to x squared times integral from 0 to infinity and then x power of a minus 1 divided by the bottom. Don't forget about the square here. And then differentiate both sides. Differentiate both sides. You get x power of a plus 2 here times another lnx. And then divided by x squared plus 1 power of 3 lnx. And then this lnx and lnx gonna cancel each other out. So here I'm going to trying to use this beta function, the first formula, which is the integral from 0 to infinity x power of n minus 1 divided by parentheses x plus 1 power of n plus n. However, you see an x squared here, so I'm going to do some substitution here. Let u is equal to x squared, du will be equal to 2x dx. And then our dx is gonna be 1 over 2. And the x is gonna be square root of u. But I'm going to write this as u power of 1/2 here. And then we are going to get 1/2 outside the integral. And then put lower limit, which is 0, upper limit still infinity. Doesn't change at all. And then you know u is gonna be, x is gonna be u power of 1. So u, and then power of 1/2 times this. 1/2 times this, we can write this as a plus 2 over 2 here. And then divided by this is x squared is equal to u plus 1 power of 3. And then don't forget about we have a u power of 1/2 here. du. So I'm going to minus the power a plus 2 over 2 minus 1/2. So we are going to get our a plus 1 over 2 on the top. Since we don't have enough base, so we are going to write this on the right hand side. You get 1/2 times the integral from 0 to infinity of u power of our a plus 1 over 2 divided by u plus 1 power of 3 du. So I'm going to use the first formula here. To isolate the m, we are going to add 1 to the power and then minus 1 to the power. Add 1 to the power, you get our u power of a plus 3 over 2 minus 1. Then divided by, put the m here, m which is a plus 3 over 2. So we are going to find what is n here. To find what is n here, be sure this adding this is gonna be 3. How can we figure out this? Just do some equations. This m power plus n need to be equal to 3 because we want to get the original back, right? Original power back. So to figure out what's the n, so minus both sides. Or you can just multiply by 2 both sides. You get a plus 3 plus 2n is equal to 6. So you can get 2n is gonna be our 3 minus a. So you get n is equal to 3 minus a over 2. So you are going to get this n is gonna be plus our 3 minus a over 2 du. So here we can finally use our beta functions, which is 1/2 beta. I'm going to write this as 3 plus a over 2 since it looks better because we are going to follow the order 3 minus a. It seems like it's beautiful. What is beautiful? It's 3 plus a, 3 minus a. So use the definitions of the beta functions, the comma version of the beta functions. So you can get 1/2 times gamma of 3. I'm going to write this as 3 over 2 plus a over 2 times gamma of 3 over 2 minus 1/2 times gamma of 3 over 2 plus a over 2 times 3 over 2 minus a over 2. And then divided by these two things adding up, you get a and negative a cancel out, and then 6 over 2 you get 3, gamma 3. So what is gamma 3? To do what is gamma 3? How to evaluate gamma 3? Minus this and then do the factorial of this. 2 factorial, 3 minus 1 is 2. 2 factorial you get 2. So 2 times 2 you get 4. So 1 over 4. And then we are going to use the second formula here. Gamma 1 plus n is equal to n times gamma of n. So I'm going to write this as gamma 1 plus 1/2 plus a over 2. And then time another 1 plus 1/2 plus minus, this time is minus a over 2. So use this formula, you get 1/4 time our 1/2 a. You can just write this as 1 plus a over 2, and then time gamma of our 1 plus a over 2. And this one you get 1 minus a over 2 times gamma of our 1 minus a over 2. So 4 times 2 times 2 you get 1 over 16 here. And then 1 plus a times 1 minus a, you can get our 1 minus a squared here. And then here you can get our gamma 1/2 plus a over 2 times gamma 1 over 2 minus a over 2. So here you get this gamma 1/2 plus something times gamma 1/2 minus something, pretty much just the fourth formula. It's gonna be our pi times secant pi n. The reason I write down the third formula because the fourth formula is coming from the reflection of the gamma functions, which is just the third question. The fourth formula is coming from the third formula, which is also known as the gamma reflection of gamma functions formula. Yes. So you're going to get this one, you get pi times our secant pi a divided by 2. So you pretty much just get I prime of a is equal to this. And then we're going to evaluate both sides from 0 to 1. Yes. So you get I1 minus I0. You're going to get our pi over 16, which is a constant. We are going to put it outside the integral. Pi over 16 and the integral from 0 to 1 of our 1 minus a squared times our secant pi a over 2 dA. So what's I of 0? When you put 0 here, x power of 0 is equal to 1. 1 minus 1, which is 0. So I of 0 is going to be 0. And then I of 1, which is pretty much just our original question. Yes. Here's kind of yes. Okay. I of 1, put it here, which pretty much just our original question. So I'm going to just write down the original question here. X squared times x minus 1 over x squared plus 1 power of 3 lnx dx. So it's gonna be pi over 16 times this integral. And how do we evaluate this integral? We are going to use the integration by part. So use the DI tabular method, the table method. We are going to differentiate 1 parentheses 1 minus a squared, and then we are going to integrate secant pi over 2. Yes. So differentiate 1 minus a squared, you can just get negative 2a. Differentiate secant, use the formula. You are going to get 1/2 times ln of this absolute value. In here, we are going to ignore the absolute value since we are going to evaluate this integral from 0 to 1. So we are going to get 1/2 times ln of this. However, though, we have a pi a over 2 here. Let me do some substitution in our head. That u is equal to pi a over 2. Du, we just get pi over 2 dA. And then dA, you pretty much just get 2 over pi du, right? So 2 over pi times this, you pretty much just get 1 over pi, right? 1 over pi times ln. And then finally, you get parentheses 1 plus psi pi a over 2 divided by 1 minus psi pi a over 2 here. Yes, divided by pi, yes. So we're going to multiply 1 minus a squared divided by pi, and then times ln of 1 plus psi pi a over 2 divided by 1 minus psi pi a over 2. And then evaluate this from 0 to 1, and then minus become positive, and then 2 over pi, put it outside the integral, and then a times ln of our 1 plus psi pi a over 2 divided by 1 minus psi pi a over 2 here, dA. So here, yes, here's, when we put 1 here, you get 1 minus 1 is equal to 0 here. Put 1 inside, you get 1 plus psi pi over 2, which is 2 here. And then 1 minus 1, 0. 1 over 0, you get infinity. L1 infinity, you get infinity. Then 0 times infinity, which is an indeterminate form. But I'm not going to do too much here. I'm pretty much just skip this here. Skip this part, the limit part to here. And then put 0, just 0, yes. Pretty much, if I do this, you get all 0 here. So I'm going to just ignore this part here, and then we are going to time our 2 over pi, and then time the integral from 0 to 1 of a times ln of 1 plus psi pi a over 2 divided by 1 minus pi a over 2 dA. Yes. So here, pi and pi cancel, and then simplify to 1 over a times integral from 0 to 1 of a times ln of 1 plus psi pi a over 2, 1 minus psi pi a over 2 dA. And here's the deal. We're trying to use the formula of this. However, though, this is 1 plus over 1 minus. And this formula is 1 minus and then over 1 plus. Don't worry. Just switch the order and then put down a negative sign outside. Because switch the order, put down a negative 1 power, but switch the order and then put a negative sign outside. You get negative 1 over a, and then integral from 0 to 1 a, and the ln. Inside you already get a 1 minus sign and then over 1 plus sign, right? Just use this formula. You get tangent square of pi over 4 minus our a over 2. It should be a over 2 here. Should we do some substitution here? I think so. I think we need to do a substitution first. Yes. So I'm going to just switch the order first. Write down as negative 1 over a, and then from 0 to 1 a times ln 1 plus psi pi a over 2. It should be negative sign here. 1 plus psi pi a over 2 here. Yeah. So do more substitution. Let 3. Let 3 is equal to pi over 2. d3 is going to be pi over 2 dA. And then dA is equal to 2 over pi. Yes. 2 over pi. dA is equal to 2 over pi times d3. So 2 and a simplify to negative 1 over 4 pi. Right. Negative 1 over 4 pi outside, and then put 0 into it, you get 0. Put 1 into it, you get pi over 2. And now a is gonna be 2 over pi d3. a is equal to 2 over pi v, not dv. And then you get ln 1 minus psi v over 1 plus psi v dv. Simplify more. You are going to get negative 1 over 2 pi square times integral from 0 to pi over 2 of v. And then use the formula once again. Use this formula, tangent square of pi over 4 minus, but here we are going to use v here. V over 2, yes. So, we are going to put a 2 outside, right? We can put a 2 outside already. 2 outside, yes, because of the ln. So 2 and 2 cancel, you get negative 1 over pi square times the integral from 0 to pi over 2 of v times ln tangent of pi over 4 minus v over 2 dv. Here, we like to try to get rid of this pi over 4 minus v over 2 here, but I want this upper limit to be the same again. What do we do? Yes, our substitution is gonna be let v is equal to pi over 2 minus t. We want the upper limit to be the same again, so let it to be here, this to be this, dv is gonna be negative dt. So you are going to get positive 1 over pi square times, put 0 into it, you get pi over 2, and then put pi over 2 into it, you get 0, the upper limit. Now v is gonna be pi over 2 minus t, and then times ln of tangent, and then pi over 4 minus 1/2 times, we let v is equal to this, pi over 2 minus t. Expand it, you are going to get pi over 4 minus pi over 4 plus t. So over you get t inside dt. So here we want the upper limit and lower limit to be switched as from 0 to pi over 2. So we are going to add down a negative sign here from 0 to pi over 2, and then this negative sign multiplied by this, you get t minus pi over 2 times ln of tangent t dt. Yes, here I'm going to use the forward series of the ln here. Forward series of ln tangent x is equal to this one. First thing, we are going to multiply by negative 2. So we put a negative 2 over pi outside. Yeah, negative 2 outside integral, you get 2 over pi. And then pi times this again. Pi times t minus pi over 2, just switch the order of this. You get pi over 2 minus t. And then the forward series is n is equal to 1. And then wait a minute, it should be over 2 here. T over 2, my bad. Over 2. T over 2. Luckily, it doesn't mess up at all. We just realized I forgot the 2 here. Yes. And then use this formula. It's gonna be cosine of x is gonna be our t over 2. So t over 2 times that, you get 2n plus 1 times t. Yes. And then divided by our 2n plus 1 here. Yes, here we are going to switch the order. We can just switch the integral sign and the summation sign here because it's converges. So you get 2 over pi times the integral, you have times the summation of 1 over 2n plus 1 in our t will be just a constant. Forget dt here again. 1 over 2n plus 1 is a constant in our t row, so you can put it outside the integral. And then times the integral from 0 to pi over 2 of pi over 2 minus t times cosine of 2n plus 1 times t dt. So I'm not going to show you how to do this integral in this video because since we don't have enough space here. Yes, so I'm going to check what's the result of this integral here. Sorry guys, because we don't have enough space here. So pretty much this integral you are going to get is equal to 2 over pi and then time this m plus 1. This integral is gonna evaluate to 1 over 2m plus 1 square, like that. And then this time this you are going to get 2 over pi times the summation when n is equal to 1 to infinity, and then 1 over 2m plus 1 power 3. Yes. Do I mess up here? Do I mess up something here? Let me check. Oh, it should be 0. Yes, it should be 0 here. 0, 0, 0. The 4 series, I copy the 1 formula here. It should be 0 here. And when n is equal to 0, and then we are going to change this. Change this, change this. So this integral you are going to evaluate to this one, 1 over 2m plus 1 squared. So therefore, these summations just here, which is equal to 7 over 8 times theta phi. So far, this is 7 over 8 times theta phi. Hey. Wait a minute, one answer again. Yes, pi square, pi square. I forgot the square here. It's a big mistake. Square, square, square. Oh, finally, we get our result is equal to 7 times theta 3 times pi square over 4, which is 7 times theta 3 over 4 pi square, which is just our result. Really cool, huh? Finally, yes, this is just our result, and bye.